In this video, we're going to take a look at algebra again, but this time we're going to think about how to multiply algebraic terms together. So let's again think about what we're doing when we multiply numbers together. So if I have 4 times 4, one way we could think about that is that we're doing 4 squared. And yes, I know the answer is 16, but that isn't going to help us when we start applying this to algebra. So let's just think of it as 4 squared. And if I did 3 times 3 times 3 times 3, well, I know it's 81, but I'm thinking more that we could actually write it as 3 to the power of 4. And this 4, well, that is how many times we are multiplying 3 by itself. So let's now think about some algebra and some letters and see if we can apply those same rules. So if I start off with an A and we do A times A times A times A, let's have 4 like that. Well, that will be A to the power of 4. It's how many times I've multiplied A by itself. It's going to be 4, so I'm writing that as the exponent or the index here at the top. If I had B times B times B, that would be B cubed. Now, that's an interesting and very useful starting point. So now let's think about what would happen if we brought in some different letters and more letters into the same expression. So what about now if we think about X times Y times X times X times Y? Well, it doesn't really matter about the order, does it, when we multiply? 2 times 3 is the same as 3 times 2, for example. So this is exactly the same thing as putting those x's together, followed by those y's. So this is going to be exactly the same. And I already know that first 3 x's is an x cubed. And I also know those 2 y's at the end, that's a y squared. So this is going to be equivalent to x cubed y squared. But of course, if you remember from the previous video on collecting terms, we don't need to write that multiplication sign there. So I'm going to write this just as x cubed y squared. So let's now bring that again and make that a little bit faster. Let's try a different one. So how about now we consider A times B times B times A times C times A times A times A. Well, let's count up how many A's we've got. I can see 5 there. So we've got A to the power of 5. I can see 2 B's. So we've got B squared. And I can see a C. And I'll just write a C at the end there. I could write C to the 1, but it's better to write the C as it is. So that will simplify to A to the power of 5, B squared, C. So from there, we can now introduce some numbers into this and so sort of bring our previous work forward and apply it to this multiplication context. So now let's consider something along the lines of 3A multiplied by 4B. So 3A is the same thing as 3 times A, and 4B is the same thing as 4 times B. So this is certainly true, this statement underneath. And again, we can move this stuff around because it doesn't matter of the order when we multiply. So this is equivalent to 3 times 4 times A times B. Well, now we can see that 3 times 4 is actually 12. And the A and the B can be just written like that, as we've seen in the past. So this will simplify to 12AB. Let's look at another example, and now we'll move it a little quicker again. So what if we said 3A times 7B times 2A? So thinking we can move this order around and collect up the terms as last time, we could say, well, 3 times 7 is 21, and times that by 2 is 42. So certainly, if we deal with the numbers first, we are going to have a 42 at the front of the simplified expression. We've also got 2 A's, and A times an A. We've got one here, and we've got one here. So that's going to mean we've got an A squared. And finally, we've got this B, so we better write that in as well. So this expression is going to simplify to 42A squared B. We could go even further than this, though. Let's just go and do an extension question now. What about if we considered 3A squared multiplied by 10A squared B multiplied by 5A b to the power of 3. Well, in just like the previous case, we can bring those numbers together. We can think about how many a's we've got, and we can think about how many b's we've got. And I'm going to explain this in quite some detail, but we can certainly move through this a little quicker in a moment. But we're going to have 3 times 10 times 5 as our number, all right? And we can see where that is coming from. And in terms of the a's, well, my a squared is a times a, and my other a squared next to the 10 is also an a times an a, and then I've got that a next to the 5 as well. So we have actually got 5 different a's, 2 there, and 1 there. And then we've got the b's. Well, we've got a 1b, which is there, and on the end we've got 3 timesing together. So let's write that down. Okay, so I've broken up this expression into its component pieces, and now let's put it together. So 3 times 10 times 5 will give us 150. If we count up those a's there, we've got 5 of them. So this is equivalent to a to the power of 5. And if you look at the b's, we've got 4 of them. This is b to the power of 4. So our simplified expression is going to be 150 a to the power of 5, b to the power of 4. We'll go one step further and do this one quicker. This is going to be the last check now. So have a quick think about this next problem. 2x cubed y to the power of 7 times 10x y to the 2 times 9x to the 20 y to the 8. So have a think about this. The number at the front will be 2 times 10 times 9. Well, that is going to be 180. X cubed times x to the 20 is going to be x to the power of 24. Y to the 7 times y squared times y to the 8 is going to be y to the 17. Okay, so there's our simplified question. I hope that you've understood that and that helps you to answer the question set.